Water purification systems. Providing safe, potable, drinkable water to large cities is a complex undertaking that relies heavily on sophisticated purification systems. The process doesn't simply involve removing visible dirt. It's about eliminating microscopic contaminants like bacteria, viruses, parasites, and harmful chemicals. Typically, city water sources originate from rivers, lakes, or groundwater aquifers. Initial treatment begins with coagulation and flocculation, where chemicals are added to cause tiny particles suspended in the water to clump together, forming larger, heavier masses called flocks. These flocks are then easier to remove through a process of sedimentation, allowing them to settle at the bottom of large tanks. This initial stage significantly reduces turbidity, the cloudiness caused by these particulate matters. Following sedimentation, the water undergoes filtration. This often involves passing the water through layers of sand, gravel, and charcoal filters. These materials act as a physical barrier, trapping remaining suspended solids and some larger microorganisms. However, filtration alone isn't enough to guarantee safety. The crucial next step is disinfection, traditionally achieved using chlorine or increasingly with alternatives like ozone or ultraviolet UV light. Disinfection eliminates any surviving pathogens, disease-causing organisms, ensuring the water is biologically safe for consumption. This process leaves a residual disinfectant in the water supply, protecting it from contamination as it travels through the extensive network of pipes to homes and businesses. Despite these robust systems, cities face ongoing challenges in maintaining water quality. One significant problem is agricultural runoff, which introduces pesticides, fertilizers, and animal waste into water sources. Another concern is aging infrastructure. Corroded pipes can leach lead and other metals into the water, posing serious health risks. Furthermore, emerging contaminants like pharmaceuticals and microplastics are increasingly detected, requiring advanced treatment technologies to address them effectively. These issues necessitate constant monitoring and adaptation of purification methods. To combat these problems, cities are investing in innovative solutions. Advanced filtration techniques, such as membrane filtration, microfiltration, ultrafiltration, nanofiltration, and reverse osmosis, can remove even smaller particles and dissolved substances than traditional sand filters. Activated carbon adsorption is used to eliminate organic compounds that cause taste and odor issues, as well as certain chemicals. Moreover, cities are implementing stricter regulations on industrial discharge and agricultural practices to minimize pollution at the source. Replacing aging pipes with corrosion-resistant materials like ductile iron or plastic is also a priority, though a costly one. Ultimately, providing clean water is a continuous cycle of treatment, monitoring, and improvement. While current purification systems effectively address many common contaminants, ongoing research and development are vital to tackle emerging threats and ensure the long-term sustainability of our water supplies. The health and well-being of urban populations depend on these advancements and the dedication of professionals working tirelessly to safeguard this essential resource. Vocabulary list. Questions. Choose T for true or F for false. 1. Coagulation is a process used to dissolve microscopic contaminants in water. 2. Sedimentation relies on gravity to separate heavier particles from the water. 3. Filtration alone guarantees that water is safe for human consumption, eliminating the need for disinfection. 4. Chlorine is no longer used as a disinfectant due to its negative impact on taste and odor. 5. Agricultural runoff can introduce harmful substances like pesticides and fertilizers into water sources. 6. Aging infrastructure, specifically corroded pipes, can contribute to lead contamination in drinking water. 7. Microplastics are a newly identified contaminant that traditional purification systems easily remove. 8. Membrane filtration is generally less effective than sand filtration at removing small particles. 9. Activated carbon adsorption primarily targets biological contaminants like bacteria and viruses. 10. Replacing aging pipes is a relatively inexpensive solution to water contamination problems.